With short circuit welding, we have to feed the wire at a typical wire feed rate of 100 to 350 inches a minute. That's 2 meters to 9.5 meters a minute. This will deliver an approximate short circuit current range of 70 to 200 amps. When welding thin gauge carbon steels or stainless, start out at the easy to remember 10 o'clock position. If you need more or less heat or weld, increase or decrease the wire feed by 1 turn. Remember that's 70 inches a minute or 1.8 meters per minute. The next step is to set the short circuit welding voltage. The voltage range for short circuit is 13 to 23. An optimum range is 16 to 18. Why not start out at the easy to remember 17 volts? So far we've talked about the basic requirements for short circuiting. Voltage in around 17, 18, wire feed around the 10, 11 o'clock position, or you could even start it off in the middle as long as you're in the range. Let's look at some real applications with one objective in mind. We don't want spatter, and we want to do all these applications on one simple setting. Applications like, 10 gauge plate, vertical up. Applications like 60 thou material, fillet weld. How about a root pass in a pipe? These are basically short-circuiting applications. Remember, the simple rule is if it's less than 1/8 of an inch, or it requires vertical up or vertical down, or you're welding a gap, you simply think of short-circuiting welding. We go over to the machine. With the voltage, we adjust the voltage to strike an arc on the plate and watch the meter so we've got 17, 18 volts. With the wire feed, we simply set the wire feed in around the 10 or 11 o'clock position. And now let's look at the 1/16th application. Again, we will use the same parameters with the objective of a complete spatter, a spatter-free weld. It's important when short-circuit welding to listen to the sound of the arc. For short circuit, we need a constant, smooth, rapid crackle sound. If the arc produces a harsh, irregular, high crackle sound, then the voltage is too low. If the arc produces a soft, plopping sound, then the short circuit voltage is too high. As we examine this 1/16th plate, we look at the weld. We can see again, absolutely there isn't one piece of spatter on the plate. And it's really not so much welding technique as it is simply setting those parameters where they should be. When setting the wire stick out for short circuit welding, and you're welding less than 150 amps, keep the contact tip outside the nozzle. This allows a short wire stick out using low voltages. Typically a wire stick out of 3/8 of an inch or about 10 millimeters is ideal for low current applications. When welding above 150 amps, recess the contact tip inside the nozzle and try and maintain about a 1/2 inch wire stick out. maintaining a 1/2 inch again allows the use of the 17 to 18 volts. The object in short circuit welding is always utilize the lowest possible voltage.
Short circuit wire selection. When welding continuously on sheet metal less than 045, use 030 wire. When welding on sheet metals more than 045, use an 035 wire. If using straight CO2 gas, use a high silicon wire, such as an E70S-6. When welding coated or galvanized steels, avoid the E70S-6 wires. High silicon wires promote cracking. Use E70S-3.
When you select a welding gas, for short circuit welding, there are certain factors that need to be considered. If you're welding on very thin metals, less than say 60 thou, then it's wise to use an argon mix which doesn't have a lot of reactive gas in it. What does that mean? Well, the typical mix in the marketplace is 75 argon, 25 CO2. But if you're going to weld on 25, 30 thou materials or weld along the edge of a sheet metal, then why not use argon with we'll say 2% oxygen? Why does this benefit your application? Well, simply from a point of view that argon oxygen uses less voltage than argon CO2. For example, with argon CO2, you would require 16, 17 volts to keep a stable arc. But when you get into argon oxygen, you can work at 13 and 14 volts. Again, where should you use argon oxygen? On sheet metal, where you want to weld along the edge of a sheet metal, on sheet metal, say less than 40 thou, you will find it extremely beneficial to use 98 argon, 2% oxygen. When you're welding on an application such as this, where it's just over 1/8 of an inch and you want to put a nice bead without spatter, you obviously need more heat. Using now 75 or 80 argon and 20% CO2 is fine for an application like this. But if you constantly weld in a shop and where you're welding on sheet metals and you never go above 1/16 of an inch, then it's wise to use maybe 8 to 10% CO2. After all, you know, when you're welding sheet metals, the object is not to burn through. And if we can reduce the heat just a little bit by reducing the reactive part of the gas mix, then it makes it a little easier.
Short circuit gas selection. Characteristically, CO2 creates a digging effect, which reduces arc stability. Utilizing CO2, the arc is hotter, influencing burn-through potential on thin metals. With CO2, the volt and amp range is very narrow, which makes it difficult for the welder to obtain optimum arc stability. Using CO2, the spatter level increases with an increase in current. CO2 promotes more surface oxides, which should be removed before painting. The material thickness, joint type, and weld position are the prime factors in considering an optimum gas mixture for short-circuit welding. On metals less than 035, argon oxygen allows the use of lower voltages, which reduces burn-through potential and minimizes damage to coatings on the opposite side of the material. Remember, the thinner the sheet metal, the less heat it requires from the welding gas. These mixtures provide the required level of arc energy with optimum arc stability. For increased arc energy, a slight increase in reactive gas improves penetration and weld fluidity. For root passes vertical down or filler passes vertical up on pipe less than 3/8 of an inch thick, use argon 15 to 25% CO2. This provides penetration and arc stability. If the pipe is thicker than 3/8 of an inch, CO2 is required for the filler pass to provide sufficient sidewall fusion. The most practical gas mix for a plant using bulk would be to set the mix at 15 to 20% CO2.
If you look at short circuit welding, first of all, simply look at the application. If you're welding overhead or vertical up, if the plate is less than 1/8 of an inch, if there's a root gap or a large gap that you have to fill in, then simply think short circuit welding. In this video, you have heard reference to the wire feed clock positions for setting the wire feed speed or the current. When setting MIG parameters, the clock method makes parameter selection simple for either setting a traditional wire feed control or a digital control. A typical wire feed control provides 650 to 750 inches per minute. The average wire feeder therefore provides 700 inches a minute. Each turn on the wire feed control would provide 70 inches a minute or 1.8 meters a minute. At the 7 o'clock position, the wire feeder is off. 8 o'clock, 70 inches. 140, 210, 280. The 12 o'clock position is the 5th turn. 5 times 70, 350 inches a minute. 420, 490, 560, 630, 700 inches a minute. The practical short circuit wire feed range on the wire feed control is 8 o'clock to just past 12 o'clock. That's 70 to 400 inches a minute, or approximately 2 to 10 meters per minute. The majority of short circuit welds made with an 035, 040, or 045 wire are made in the welding current range of 100 to 220 amps. With 035, 1 millimeter, 040, 1.1 millimeter, or 045, 1.2 millimeter electrodes, 90% of all welds will be carried out between the 9 and 11 o'clock position. The voltage range that's most widely used with short circuit welding is 15 to 20 volts. However, most welds are made between 16 and 18 volts. But let's keep things simple. 17 volts is an optimum voltage setting. So why not remember 17 cups of coffee at 10 o'clock?